All right, hello. I thought I'd go over some more sort of general C# stuff, specifically sort of the difference between classes and structs and sort of enums and interfaces, just on like in a basic sense. I also plan to do another thing on like more specifically going into inheritance in interfaces, and then also how to use generics with that. But for now, I'll just be going over like the basic idea of that as well. Classes and structs are pretty similar, and enums and interfaces are sort of different things. But in terms of these two, you've definitely used classes. A monobehavior is a class that's inheriting from monobehavior. You might have used a struct. I don't know. It's not necessary, but they're very helpful. And then hopefully you've used interfaces. They're pretty helpful too. And you probably use an enum, but I don't know. So, to put simply, a class is a reference type, like strings and arrays. This means it can be null. They can use inheritance. They're the only thing that can use inheritance, I believe. Yeah, they're the only thing that can actually use like class inheritance. Only classes can inherit from another class. They can also inherit from interfaces. They have a default parameterless constructor, which I'll explain a little bit what that is exactly. But it can be overridden, so you can make your own constructor that doesn't take in any parameters for a class. And they're generally intended, like the most of your code, most of your program is going to be classes. Structs are very similar. They have some sort of subtle differences. And basically every language has, or at least a lot of the languages I'm familiar with, some don't, I think some are. Any object-oriented language, I want to say at least, is going to have classes and generally is going to have structs. And every language does them a little differently. The way C# does it is structs are value types, like an int or a bool instead of a reference type. They cannot be null, usually. You can do something to make them nullable, but by default, they are non-nullable, meaning they will always have something. Like you can never have a null integer, for example, and you can never have a null struct. They cannot use inheritance, at least not normal inheritance, like class inheritance, but they can inherit from an interface. So they can use interfaces, but not class inheritance. They also have a default, they can also use constructors and have a default parameterless constructor, but it cannot be overridden for structs. So it will always have that. And it'll just do basically nothing. And they're generally intended for holding a small set of data to make them easier to move around, to pass into functions, stuff like that. They can also have functions inside of them, and that's usually used to manipulate the data with them. Kind of like a scriptable object in concept, in a way, where it's meant to kind of hold data and do some stuff to that, but built into the language. You have enums, which are sort of like, it's basically a set of keyword and value pairings, more or less. It's very similar to a dictionary in concept. Basically, it's a set of numbers that can be represented in code through words, more or less. The values can be any number type, so it can be an integer, it can be a long, it can be a short, it can be a byte, it can be whatever. Values can also be bit flagged, which is something I'll explain in a little bit. It's kind of interesting. I just learned about this. And yeah, in principle, it works similar to a dictionary. Interfaces are kind of a weird thing. They hold a contract of elements that must be incorporated in any class or struct or other interface that is inheriting from it. They can incorporate these four things, which I got off of the documentation here. So methods, properties, indexers, and events. These two are probably the most important that you're going to be using a lot. Indexers I've actually never used personally. I can say like we can do it. They're kind of interesting. It's similar to a property, but it sort of uses like an array to hold data. And then you can get like, instead of like getting a property, you get a specific element from an array. So it's like a property, but for an array that actually can like get a specific thing. And events are events. That's a whole nother can of worms. But I can hold them. And that's basically the overview up here. To show you sort of some tests how it works. Like if I try to inherit get rid of these struct. If I try to do an inheritance from down here test parent, it'll work only for the class. It won't work for the struct or any of these other things. It won't work for this. It'll give you an error. It won't work for an enum. No, it won't work for an interface. Or will it? Oh, it does. Oh, no, it doesn't. I was like, wait, does it? No, it doesn't. So only classes can inherit from classes. Also, I've never actually tried this. What happens if you inherit a class from itself? Does it just implode? Or is it probably just errors, right? Does it like, okay, it doesn't. It gets confused. That makes sense. I just never tried that. Yeah, let's just Control Z back. If you do an interface, actually, if you do a struct, I don't think you can make them inherit either. I actually never tested this, and I assume it's just going to error sample struct, because I also, yeah, it's not going to do that. It's probably, yeah. You can't inherit structs. Structs basically are just data containers. They obviously don't do inheritance. So if you do, what's the interface? Test interface. This will work for basically all of these except an enum. So it'll work for the class. It'll work for that. Obviously, won't for the enum because enums are basically just a dictionary. And it'll work for interface. So that's basically how inheritance works with these four things. Only classes can inherit from classes, and then interfaces can inherit to anything except enums, which are just sort of here because I wanted to explain them. So don't remember that. So that's sort of inheritance. In terms of how, going more into how each of these work and going through those points, classes are reference types. So what that means is like they can basically reference type means it can be nullable, and instead of being a value itself, so like an int, right? Int x equals 1. You know, x is 1. So if I take all right, hi, interjecting because I kind of butchered this. So basically, the difference between a reference and a value type has to do with what it's pointing at, and I didn't really explain this well, but so say you have an int, right? So public int, I did not do that right. Public int x equals 1, and then you have another int where you do like, oh, public. Did I mess something? Why is it? Oh, yeah, you can't. I'm in a function. It's like, what's the matter with me? So you do int y. Now if I do right int, int value equals x, and then I do int x equals 110. There's sent. Actually, I don't need that int. Yeah. So what happens here, right, is x is 1, and now we're down here. We're in value is 1, x is 1, and now down here value is still 1, but x is now 10. So value is not linked to x, it just gets set to it. But if you have a reference type, which we have down here, basically the same thing, we have ref type that is an int. If we come down here and we do, ref type r equals new, make a new one. If we now do another ref type, r dot x equals 1. And now I make another one, we do r type ref type value, or I guess reference equals r, and then we do now we do r dot x equals 10. So we do basically the same thing here. So what happens here is r dot x equals 1, r dot x equals 1, reference dot x now also equals 1, and now come down here, r dot x equals 10, and reference dot x equals 10. And this is because, unlike this, where we just have a value, a discrete value, what we have here is like it's just looking at this. Like there's only one of these, so you can tell because the new keyword, we only created one of these. And this is just looking at this. So it just sees, oh, this is, so this dot x equals this, and this dot x is also looking at the instance of this. Like they're both looking at the same thing. So if I change one, this goes the other way too. So if I do, reference dot x equals 100, we're now in it's the same thing where both of these will go to 100. You know what I mean? And if I, do any changes I make here, if I delete it or if I do anything, changes here. So for example, if I were to like delete this, say it was like a mono behavior and I destroy it, then both of these would be looking at something that doesn't exist, so they'd both be null. So basically a reference is looking at something, whereas a value is actually like a discrete value that only like changes specifically. Basically, all reference types will eventually look at a value, more or less in some way, or at least usually, because you need numbers. Like a reference type by itself is just looking at something. So, say for example, a game object. A game object, is a class. All classes are reference types. They're looking at something that has data. Like a game object has like a mesh and it has all these other components that have like actual discrete values on them. So reference types are just ways of organizing that kind of stuff. And that's sort of the main tangible difference. Where, classes are this and classes are reference types and structs, like ints, are values. Anyway, back to what I was talking about. String is a weird example, but string is actually an array. So I guess I just do int array, x array. I can set this to null, but I can't set this to null. It'll error, right? So the main way to tell something is a reference type or a value type is if you can set it to null. Value types can never be set to null. That's probably the biggest distinguishment, whereas reference types can be. Right, so you can't set this to null. And same with structs. If I do, sample struct, sample struct equals null, it errors out. But if I do sample class s class equals null, it's fine with that. So you see the same thing happening here, where the struct is basically similar to an int, where it's a value type, whereas the class is actually like a nullable thing. It's a reference type. Another example reference type would be, a string. Pretty sure you can set those to null. Yeah. What else is another good one? I mean, a game object, obviously. Any class. I mean, game objects are also classes, And a good way to tell, at least in Visual Studios, you'll see like these color codings. Like this sort of green is a class. This is a struct. This is lighter green. And this really light green is an interface or an enum. I think some other things use this light green thing. But yeah, so that's sort of that difference in color. But you can also just hover over it and it'll tell you struct or class. They also have different symbols. Yeah. So that's sort of what nullable means. It just means like you can set to null or you can't set to null. And that's the main difference between a value type and a reference type. One over inheritance has a default. Oh, constructors. Constructors are another thing. So if you create a function in a class or a struct that uses the class's name, so it always has to be public sample class. It doesn't return, like there's no void, like usually you do like, int or void or whatever. None of that. You just public, like just always has to be public class name. And then brackets, this is called a constructor. And you can also do a destructor. Actually, I learned how to do C++. I want to see if it works the same way here. Is it the same syntax? I don't think it is. I would need to look into it. Destructors also exist, but Unity has its own systems for that. I don't know a whole lot about that specifically. But so what you can do now with this, you can also actually do parameters. So I do int x, right? And now what I can do is I can actually create a new sample class. Actually, I can do this anywhere, by the way, not just in the class. I can come down here in the struct and do sample class. Actually, no, it's keyword. S class equals new. Sample class. You don't have to include sample class. You can just do new without it. I'll do the same thing. And you can see it'll prompt me to put in an int. And it will. Oh, well, you can't do that in a struct. It's mad at you. You can't do the new thing in a struct specifically. I could do like this: private void test. There you go. You can't initialize things in a struct. That's another thing. Doesn't like it. But yeah, so you see I can put an int. If I now add like another like float z or whatever, that's not how you spell float, it'll get mad at me because that constructor now takes 2 parameters. So I have to add, 1f or something. So that's a constructor. And what this does is basically when I create this class, it'll run this immediately. You cannot do this with mono behaviors. Because you don't do that with new, you do an add component, which kind of sucks. It's actually a big downside of mono behaviors is you can't do constructors like this. So you usually have to create an initialization function on the mono behavior. and then just run it, which is kind of a pain. You can also do stuff in awake, kind of works. It's kind of weird though sometimes, because it runs like this runs would run before. Right? I don't know, it's weird. But yeah, so this is a constructor. So anything I put in here would run immediately. So say I put, let's get rid of these. I do int x, and then I could do, in here I could do, x equals, it's kind of confusing. Let's try this like starting x. I can do, and now what this allows me to do is I can create this, get rid of this just to make it simpler. Whenever I create this class, I can immediately just pass in a value that will then go in and become starting x. So I can, I can create like 5 instances of these that each have different values. It's the same value. And what all these classes will have their x variable be different values. And also, this is private, right? You don't even need to make necessarily, like, say you just want to set a variable on a class when you create it, but you never want to change, but it's a variable that needs to be specific to that class. You can use constructors for that. There's also a concept of a read-only variable, so private read-only. And this is actually specifically with this idea. This is another big downside of mono behaviors is you can't basically use read-only variables ever. What this means is I can never change this variable. It can only be set in a constructor and then never again. So if I come into here and set like private void test, and now I try to do x equals 4, it won't let me because it's read-only. But it will let me in here because it's a constructor. So that's a cool thing with constructors that you can't do with that you can't do with mono behaviors. If I get rid of that, it'll let me. But yeah. But there's a downside with read-only variables that you can't serialize them, or at least it seems like it doesn't want you to. It causes serialization issues, but that's not always an issue. Anyway, so right, you can create a constructor in a class, and you can actually create as many as you want. You can create like infinite of these. It's the same sort of rule with overloading in general, where it just needs to have different parameters. So I can make one with none. I can make one with, so I get mad at this because x doesn't exist. And I can make one with like a string. And you can make as many as you want, and what happens is when you go down to like create a new one, sample class s5 class equals new. Once again, you can just do new, you can actually skip that. And you see you have all of these, you have these 3 different constructors up here. So you can have multiple. You have as many as you want. I don't think there's a limit. Maybe there is, I don't know. If there is, it's a pretty high amount probably. But yeah. But the big difference between classes, and I'm gonna get rid of all these other ones now that I've kind of shown that. The big difference between classes and structs is you can create a constructor in a class that has no parameters, like this one, but in a struct it does not let you. So if I try to do public sample struct, and just do that, it will yell at me. But if I do the same thing, but with a parameter, it won't. So you have to do a parameter if you want to do your own struct or constructor. Int y, like that's fine. Basically all structs have are just guaranteed. They have their own internal one. It's not that you can't use it. You can absolutely still do, like, no matter what, you can always do with a struct. Find the place to do it. Test. You can always do, sample struct equals new. So there always is an empty constructor. I gotta give it a name. There always is one. You actually don't even need a new. I think it does it by default or something. Yeah, I think structs are just always, right, because keep in mind, right, structs are non-nullable. So it's like an int. So when you create a struct, it basically it exists. So if I put like a, here, let me put like actual data in this. So public int a. Whoops, why did it go mad at me? Why is it mad at me? I'm just gonna get rid of that. So I put some data in here. Actually, I should move this x. That's a bit less confusing. So I have data in here, right? And this data exists. And this is also non-nullable. So I have x in here. So I can do a.x. But it's gonna. I think it'll shoot me an error in the same way that if I do something like this, int x, and then I try to do x equals x plus x or something, it also give me an error because it doesn't know what x is, right? So we have a value type here, and inside that value type we have value types, but we don't have any data assigned to that value type. So it's basically the same thing. Like we have x here and we have x here, and both these x's exist, but the computer just doesn't know what they are, right? So in the same way, I'd have to define x before using it like this. I'd have to do like an x equals 0, and now let me do this. I also have to do it here, so I do a dot x equals so 0. And now all these work, right? You're not allowed to just do it in here, which kind of is annoying. You can usually just have classes where you just put like, you can give them default values. Like I could just make this equal to 0 by default, and then it would only get overwritten if I did something in a constructor. But you can't do that in a struct, which is a little bit annoying sometimes. But I think the general idea with structs is you're going to be assigning them data that you have. So what you're supposed to do, and this is kind of probably why you can't just do a blank constructor, because you're going to need to be putting in data to a struct. That's sort of the intent of them. So what you would do is you would probably do a public sample struct int data, and then you would do, x equals data. And that way, instead of having to do, this, you do you just do sample struct equals new, and then you would just pass in 0, and then it will set up for you. You don't need this anymore. You can just do a dot, you can come down here and just do x equals, so like this. So we can now assign this to, a dot x. So we can write it back out. And because this has been assigned through the struct, so it knows. So that's kind of I think that's probably the reasoning behind needing to have parameters on your structs or on your constructors for structs. The word struct is coming up a lot. But yeah, that's the idea. So now I'm going. Yeah, so that's how constructors with the two work. They're basically the same, and they both have a default new constructor. It just doesn't do anything really besides just create it. But you can't, you just can't use an empty. That's what a parameter, like this is a parameterless constructor, right? There's no parameters. You can't do that for struct, but you can for a class. So that's another difference. Though it's kind of small, but it's fairly important when you start doing like coding without a lot of mono behaviors. What else is there? I think the next thing is enums. I think I've gone over most of this. Yeah, I mean, the big thing, I'll go over one more thing with structs. The big point of structs is like, and they happen a lot, like, for example, vector 3 is a struct. You can see because struct. All the other vectors are also structs. They're basically just 3 or 2 or however many ints or floats in a trench coat with some functions, such as like vector 3 dot, I don't know, just dot 1, which I think just gets you one. There's also or quaternions. Those are probably struct. However the heck those work. Yeah, those are structs. Yes. So, but generally, what you would have in a struct is it would look something just like this. Like let's make this sample struct, or let's make a vector 3, right? Let's make our own vector 3 struct. You do public struct vector 3. Come in here. Then you could do public float x. X. Yes, that please. Messed it up. Thank you. So now we have all this data, and then you could also do, you'd make a constructor wherever you want to make it. Public vector 3 float x, float y, float z, and then you would assign it. This is a situation where like both of the things are named the same thing, so that's going to cause an error. What you can do is this dot x, which specifies this x instead of this x, equals x, and then just keep doing the same thing. There you go. IntelliSense is kind of a lot better. And that'll just set it. So we now have a vector 3 we can assign data to in a constructor, has the values, and then you can also just add some like, I don't know how, let's see, what else could you do that's not complicated? Oh, like something like public static vector 3 how do we do it? Return new vector 3 0 or do something like this. So when you have like a vector 3, like you do Unity engine. Let's just do a test function. Test. you do you know, new Unity engine specify, because we have the other one down here now. Dot vector 3. Oh, I did that wrong. Engine dot vector 3. I always do it like this for some reason. Unity vector, Unity v3. Then you would do something like equals this, for example, or in this case dot 1. I think in this case it's the property actually. So let's change that. Public static. How do they do it? You just do it like this. There you go. So we basically made it equivalent to this, so we can do our own version of that now. Vector 3, which should be this one. Yes. Vector 3 custom v3 equals vector 3, which once again is our own, dot 1. So that's basically how you do that. You can just make values, you can create a constructor which allows you to assign them, and then you can do stuff like this to just get default values such as vector3.1. You can then also make functions, like you can make operators. Try to see if I remember how to do that offhand. To like add them together. I don't remember offhand. But yeah, you can make custom operators to add vectors together, and you can do all sorts of stuff. So basically all the same stuff you can do for a class, but instead of being like a big thing that does all these things, it's just a small set of data that can, you can manipulate and do stuff with. So that's sort of the idea of a struct. So going on to an enum, these are pretty simple. It would just be, you would just do like, say, let's make this fruits or something. Let's do apple, orange, pear, dragon fruit, baby, pineapple. Those are things I saw at the store today. They're really cute, really like weird and small and kind of cute. Just thinking about them now. I see baby, pineapple. No, not here. They are. That's super small. It's really weird. I don't know if they just like pick them when they're like are they a separate like species, or just pick them earlier? I would hope you could eat them. I have no idea, but they're just really small, kind of adorable. They're just like they're also really painful to hold. Like normal pineapples already suck to hold, but they're like super painful to hold. It's like the spine's like way sharper. Anyway, that's good enough. So we have basically, this is the way you format enum is you just put a group of stuff like this in text, and then this is all you really need to do. This works, but you can actually get way more specific. So for example, by default, what happens is actually, I think if you hover it over, you see it assigns these to a value, right? So apples by default 0, 1, 2, 3, and 4. But you can assign them to your own value. So I can make this, 51. And now all of a sudden I believe it's going to reset all these. So this is 51, and then basically each one's going to increment up by 1 by default. If you set this one down to 2, which you can also do. So this is 51, this is 2, and then I think it's going to increment back up. I actually kind of curious what happens if I do this to like 49. So 51, 49, 50, 50. What? Okay, that's interesting. I thought that would cause an issue. It probably does. So apparently you can break it maybe if you do that. I don't know, maybe it figures itself out. Because those are at the same value. But anyway, you can assign values. So you can do a lot with this. For example, you can have something like 110. I actually think I did something with this in a tool for the tile tags, where like every different tile type's tags is like 1 more 0, or it's like in a certain range. So I can do that through code. So there is definitely utility to assign these values or whatever. Apparently something the same value, so maybe that's intentional. Whatever, but yeah, you can set their values. You can also define what type of number it is, right? So by default, it's an int. You do it the same way you do inheritance, right? Where you do a colon and then what it is. By default, I think it's an int, but you can also make it a long. I don't think you can make it can you make it a float? Does it take it? It does not. It has to be a whole number type. So you can do long. I think there's also something called ulong. So I think there's one called ulong long. Is that one? No, I made that one up. Short, which is like smaller than an int, and this is the smallest number type, which is byte, and that is 256. Ooh. 0 to 256. In all honesty, you probably usually want to use a byte just because it's a little bit smaller, but also it probably doesn't matter that much. If you're going to be saving a bunch of enums or doing something with a lot of things that are going to be represented through an enum, then it might be good to do bytes. Because now, basically, instead of, say you have a game object, like this is sort of the backbone of like the tile grid system a little bit. Instead of like saving out where all the assets are, it just saves out an enum representation of like the type of tile and what asset number it is, and that way we can like save out a bunch of them. So enums are really important for like, they can be really helpful for serialization and simplification of representation of stuff, which can make it it's a lot easier to represent something complicated that has like a lot of big data stuff like models and stuff by just using like enums to kind of encode it. Can be really helpful. But yeah, it's a pretty simple idea. You can also apparently, something I found while looking into this before I started recording this, you can also do a thing called a bool or a bit flags with enums, which are kind of interesting. You can use like bitwise operators. I'm gonna see what happens if I just copy paste this. I see I need that thing up there too. And then you need apparently flags. What does it say? It says some attribute. Yeah, flags attribute. So apparently how this will work, and you can see it also represents the numbers. And here's a little lecture in binary counting. This is 1. This is 2. You can see it doubles, and the way this works is like if I were to do this, it becomes 5. This is technically what, 6. I'm doing this wrong. Yeah, that is. Wait, I think that's 6. This is 6. This is 7, and then that's 8, and then 9, 10, 11, 12. It just goes like that. So this is just some binary counting. But anyway, I actually have no idea how this even works. Some binary representation, and then this what this does is I would think it would basically, it takes, this is the bitwise OR operator, so we can equals either 64 or 32, which would either be what would that be, either 0 0, you can see them right there, it'd be either 1 0 0 0 0 0 or 0 1 0 0 0. So it'll see like if the bit is in either of these two places basically. So that's why that works. If there are both this, I don't think it'll work. It might not work if it's this either. I'm not sure. But yeah, I think that's kind of how it's working. But that's something you can do and you can look more into. Though I've never had to use this type of enum. It's just kind of a cool thing. Probably could be really useful for like settings. Like say you have like some sort of complex like camera setting system with like a bunch of different like flags you need. This can be a good way, like flag systems like this can be really good for when you need to have a bunch of things that can be toggled on and off. Like say you have like 3 different things that can be on or off and they all affect the same thing. So you can have these things sort of layer on. Like for example, text, right? I think it's an example you see a lot where it's like, say you want to have like text that's like bolded or underlined or italicized. And it can be neither or all 3 of those things. That type of bool flag system would be really good for stuff like that. I think it's usually how it's done. But you can use enums for that too, which is kind of interesting. The final thing is interfaces, which once again operate as sort of a contract. On the documentation here, that's how it's defined. That's how I've had it always explained to me. If I can, here it is. It's somewhere. I think it's up top. Yeah, contract. And basically what this means is like, say I go to the interface and I go and I add test interface. I add, a function, public void hello. And a note about interfaces, you cannot actually make functions here. Like I can't go and do like int x equals 7. It'll get mad at me, I think. Does it not get mad at me? I didn't know you could do that. I thought you just had to do empty functions. I could have sworn. Let me see what happens actually. Usually you don't do this. Let me see what happens. I'm pretty sure I thought you couldn't. You can do them in structs. Let's do. So basically now if I add sample or test interface to sample struct, it'll get mad at me, I believe. It should. Maybe it doesn't. Oh, maybe you can just have functions on interfaces. Okay, that's interesting. Well, You're not supposed to use. So I guess that's something to keep in mind. I actually didn't know you could do that. So you can have functions and interfaces too, which functions similar to inheritance. But the way you're supposed to use them is like generally the way generally you use them is more like this. Where you have basically an abstract function, right? Like this is just the concept of a hello function. And now anything that inherits from the test interface is going to get mad at you because you have to now have that function. So if you click this, you can actually have it do it for you, kind of. Um, so now it's kind of like, so you have to have a function called hello that takes in no parameters because the interface has one. So if I just take this and I attach it to like anything, it'll get mad at me now. Like even this other interface, it'll also get mad at me because it doesn't have, at least I thought it would. I need to use these more. Apparently it lets you do that with another interface now. Interesting. Oh, okay. So I think it'll get mad at me now. Here. So the interface itself doesn't need it, but if I now use the sample interface, because you have to use an interface of a class or a struct. It's not. It doesn't really do anything otherwise. It doesn't do anything by itself once it gets a contract. So now if I bring sample interface, I'm assuming it'll get mad at me now for not having hello. Yeah. So it'll have. So you can chain inheritance with interfaces, and then you just need to have all of those functions on whatever you put it on. So you don't need to rewrite hello or whatever functions you have here, but you will need to write them for whatever eventually inherits. You'll need to write all of those no matter what you do. So yeah, but the point of this is like, say it's similar to inheritance in a way, right? Where you like say you want to have a parent class and you want to have these functions that inherits those functions and variables. Interfaces are similar in concept, but instead of having to inheriting a bunch of stuff, what you're telling the program computer to do is have a class that we know is going to have this function or these functions and variables and stuff. And that way, what you can do is say you have like, let's make another sample class real quick, or actually we can do it with these two. So say sample struct and sample class. Let's also just put sample interface here. Now we gotta do hello. Public has to be public. Void hello. I think it has to be public. Well, does private work? Let's see. No, it gets mad at you. And then you could do like debug. I'm not gonna actually run this, but you do debug.log, log warning, struct. You could do different things in here, and then you have the other implementation up here and up here. That'd also be hello, but this one would be class or do whatever it does. And then what you can do is you can come into let's make another class down here. Public class interface demo. I always do it. We can create a new sample interface object. And what we can do, I did the thing again where I always do new instead of just making it. There we go. So we have interface object, and now what we can do in like private, we have to put it in a void function just because you can't just do it in the void func. We can make interface object equal new. I believe we can just make a new, what is it? Sample class. And it'll actually take that. Right. And then we can do interface object. And what this means is we can run hello. And then we can do interface object, interface object equals new sample struct. And we can also still do this. So we can basically set the same thing. Now the thing to note about this, right, is if we put a function on, specifically on our sample class here, that's not part of the interface. Like we just make a, public void class function, and then we do whatever the heck. We don't have access to this, nor would we have access to a similar thing on the struct function. We only have access to functions that are on the interfaces themselves. Like if I now try to do, well, even though it has a class on it, if I try to do interface object dot class function, you can't do it. You technically could get access to it by doing some shenanigans. You could do like you could do this. You could do new I'm thinking you probably do this. Let me try to do sample class. It's kind of a type of unboxing in a way. Class, S class, can spell class equals interface object. You can probably cast it to, sample class. And then you can check, if S class does not equal null. It's again one line if statement. Let's do the variables, maybe a little easier to read. Class. So you can do stuff like that to get access to it. But obviously, this kind of defeats the purpose of the interface a little bit. Because like the whole point of the interface is meant to be a generic set of things. It is possible to get the class out and check if it is like that specific thing. It's possible, but that's sort of not the point of the interface. If you have to keep doing this a bunch, then maybe you want to reconsider how you're organizing stuff. But it is possible. You just have to key. So what you do is basically have your interface object, you cast it to the specific thing you want, making a new variable for that type, and then you check if that's null, and then if it's not null, you do the function. Because if basically this fails, like say it's actually a struct, it should just become null. It'll just return null, and then this won't run, obviously. At least usually it's how it works. And yes, I think that's more or less everything to go over with sort of this basic overview. Bit flags, contracts. Oh, I didn't show properties for these. I don't remember how. Oh god, where am I? Start collapsing it so I can kind of navigate. Here we go. So you can also put properties on these, right? So what a property basically is, so say you have a variable. Let me just an actual thing that won't get weird about it. There goes class up here. So say you have, int x, you have your x variable. Let's make that private, and so you basically have your x variable. You want your x variable to be able to be, you want it to be private, right? Like you don't want the x variable to be able to be changed somewhere else. You want it to be basically private, but you do want like another class to be able to read it. You want it basically to be read only outside of the class it's in, but you want to be able to change it internally. You can use properties for that, and there's different ways to do properties. It's actually pretty open-ended. The most basic way is to do something like this: private int x, and then you would do public int capital X. Usually the naming scheme is usually just you capitalize it because it's public, usually in some way. And then you can see it's already kind of recommending get return x. So what this does is it allows you to only get it. So if I were to go to let's just make another class. Demo. I always do that. So do a private func. Yep. Oh god. Nope. For yep that. So let's make a new. What is it? Sample class. Sample class. I did it again. Sample class C equals that. All right, so we basically now have an instance of this class. So now we can do C dot X, and we can get X, right? So let's just do int red X. Red. What we can now do is red X equals C dot X. So we can get it and we can write it out. Like we can save it here, and we can now do stuff with red X, right? We can do red X plus plus. But what we can't do is we can't go to C dot X. C dot X equals 0. If I try to set it, it'll be like no. You cannot do that. It'll say it can be assigned. It cannot be assigned to it as read only. And the reason why that is it only has get. If I go in here and I do set, and now I do value or x equals value. So when you do set, you have sort of this incoming parameter of value. That'll be whatever the type is. And now basically it goes both ways. Basically doing this is the exact same as just making this public. Like it's literally no different. So there's no point to doing like this. But what you can do is you can do like, say you want x to always be like a multiple of 10 or something. You can make like, you can do like math f dot round. Can I do? You have to multiply this by 10 or divide it by 10. Divide by 10 times 10, and then cast it to an int. So you can do basically extra operations. So like this would round it. This would either round it down or up. Actually, I'm too lazy to think about it, but the idea is you can basically do extra operations. In your set thing, you don't just have to set it directly. You can do weird things. So it does give you some extra control. Like, so say if I come down here now, and I do x equals, 19, in theory, it would actually set x equal to 20. It would round it to 20. So you can do stuff like that. And there's other uses for this. You can do null checks. You can do whatever in this, basically. But generally, properties, this is probably the most common type of property. In fact, this exact type of property actually has a shorthand through lambda. I think it's called a lambda expression, where you don't even need to write this. You can just do, and that does exactly the same thing. You just do this little kind of equal mark arrow, and that literally just does this as a shorthand. And I usually write it like this because it's just way quicker. That's also a property. Yeah, that's kind of the basic of properties. You can also do other more fancy stuff like, say it's a reference type, say it's a string, right? And what you want to do is you want to do like, say this is, it's actually just an int array. I feel like that's something that comes up more. Int array x, and then you have int array. And you want to make sure that the array you return is never null. So what you would do is you can now actually do a null check inside the get. You can also do whatever in the get as well. Like I could just randomly return new array every time for no reason. But what I can do is if this x equals new int 0, and then I can return x. And this way I'll never have a null array when I'm reading it from outside this class. So I'll always get something. So you can do stuff like that. There's a lot of uses to properties. Basically, it allows you to add a function to the concept of just like accessing a variable. So this function always runs, which is pretty handy. Also, it's going to have an array next, it's read only again. But yeah, that's the concept of a property set. Let me just undo all this. So there's an error. Look around though. There we go. All right. So that's the idea. That's what a property is. Basically, it's not a variable itself, but it's a way to access that variable. And so you can put those on interfaces. So let me add this to this interface. So we could do, public int x get I believe you might have to also have a variable. Let me see. Or maybe you just need to have a vague, I think you just need to have a vague property. That's right. So you just need to do, is it just get, is it just like that? Yeah, okay, yeah. Yeah, I was like kind of confused for a second because I was like, wait, but how do you, and the answer is, no, you have to, so how it works is you have to have this property now, right? So this works in the same way as now we can go over to like our test property demo, interface demo, and we can also do like, debug.log interface object.x, because we always have that property. And internally, we can set that property to be whatever we want in our class, but we always have that property. So we can do that, in both cases here. We can also do that in the struct. But what this means is now on these things that use that interface, we now have to have that, basically. So both these are going to want that, I thought. Wait. Oh, because we already have one. I was like, wait, why is this one not met? Oh, I just did it there. But yeah, so we can also do it on the struct. We can implement it however we want on the struct. It just has to be called x. So, we can do public int x, and then we can do, or I guess we want to do private, would be the whole idea behind this. And then we can do public int, and we just have to, the one contingency is we have to actually call it the same thing. So we have to call it x in this case. And then get, return, we can do whatever. We can multiply by 2, and we can set it to x equals, we can divide it, we'll just make it really weird for no reason. Like, we can do whatever here. We can implement these functions however we want. We just have to implement them with this name, and it won't get mad at you. So that's the idea. You can do properties. You can also do indexers, which are, I don't really know fully. I've never used them. it seems like what they are is it's a very similar idea to a property, but it works instead of accessing like a variable, it accesses a specific item inside of an array. That's something I need to look more into, but that's also it is a thing. I've just never had to use it, but it does exist. And finally, it also does events, which it means like native events. Not too familiar with these types of events. I usually use system.action. But these also exist. There's a lot of ways to do events. So there's more to that. And yeah, and also the final thing to note here, right, is on this one interface we have just a property. On this other interface we have test interface. We have that function. So on any interface that inherits from, sample interface, which inherits from test interface, we need both of these. But if we were to just inherit from test interface instead of sample interface, we wouldn't need this. We would just need what's on this. It's sort of a chain of inheritance. So if I go here instead, now I can remove X. It gets mad at me down here because it's just, obviously it's an interface, but I can get rid of that and it won't get mad at me up here. And another thing to note is just in terms of quantity. Basically, you can only inherit from one class. So say I have another like inheritance. Let's do demo. You can inherit from, test parent. You can only inherit from one class, but you can inherit from as many interfaces as you want, basically. So I can inherit from sample interface, or nope, sample interface, test interface, which I think would be kind of redundant. But in this case, or how do you, there's a way you have to format it, or maybe you do them first. Because you can inherit from a bunch of things in this way. Let me try to remember. I think is it a colon? So just like that. Here, let me go and show you it's inherent from each other. I know you can do it. I'm just reading the syntax right now. C# inheriting from both classes and interfaces. Yeah. Why is it mad at me? I'm so confused. Oh, is it just max I didn't? Oh, it's because I didn't implement them. Ah, that thing I mentioned. There we go. And then test interface. There we go. Yeah, so you can inherit from only ever one base class, but as basically as many interfaces as you want. In this case, this is also interesting because we have a test interface which wants just hello, and sample interface which basically wants both hello and X. So if you have redundancy in interfaces, you only need to implement one. Because you can't really implement two, but it doesn't get mad at you. That's kind of just an interesting edge case. So you can have like an interface that has like some shared elements of another interface and still inherit from both of them without an issue. At least in terms of like the code won't it'll compile it fine. So yeah, you can inherit from as many interfaces as you want, but only ever one parent class. And I think that's basically it. The only other thing to mention, or at least thing I wanted to mention was, do I still have it opened? Where is it? Here it is. There is apparently something kind of new from 2023, or I think it was a few years ago, C 9.0, called a record. I don't really know what it is. I've never used it. It's a similar thing. It's sort of like a data structure, it looks like. It does something. You can have properties and fields. So I guess variables and properties, basically. And they're mutable, which means you can change them. And they have some stuff. I don't really know what they're used for. I've never used them. They have some inheritance support, which is interesting. But so there's some new stuff. This language is always changing over time. Languages are always evolving. But this is a new thing, relatively new thing. But I don't really know if it's super important, or it seems very niche. I just found it while like researching stuff for this. But yeah, I think with that, that's more or less everything. Once again, a quick overview of, classes are nullable. They can use any inheritance. They can have a constructor that takes in no parameters. You can make your own custom parameterless constructor, and they are generally the bulk of your program. Then you have structs, which are a value type like an int or a bool. They cannot be null as they're a value type. They cannot use class inheritance, but they can use interface inheritance. They have a default parameters constructor, a lot like classes, but you cannot overwrite this one. You can't change it. In large part, that's due to the fact that they're intended to hold small amounts of data. So the idea is you're going to pass in data when you create it usually. Enums are just sort of basically a dictionary of a string to a number. They're good for just like representing things with numbers, and it's good. Like it's better to program with enums than just having like if value equal 1, then do this. If value equal 2, do this. Like basically, it's a way to make those type of switch statements where like say you want like the fruit to be a pear if it's 1, or you want the fruit to be a pineapple if it's 2, or an apple if it's 3. Well, it makes it a lot more readable if you do an enum instead of doing like if 1 it pear, if 2 it apple. This is just a way to do that type of thing, which can come up a lot. And then interface is a whole other thing. It's basically a contract for functions and properties, as well as events and indexers, which I didn't really go into, but it basically acts as a way to ensure that a function or a class or a struct or another interface will then later promise that from a class or a struct. In the demo, you can see how it works. That's not the right demo, and this demo kind of went over that. Is this the right one? I should probably read this one, where basically we can put anything from the interface and then we can run functions from that interface. You can also figure out what it is specifically if you really need to, though that's kind of weird. And then yes, that's basically it for this sort of overview. I'll probably be going over more about like different types of thinking sort of like when to use inheritance versus interfaces versus that sort of generic using generics for stuff, like different times to use those and how you can kind of use those together, do some really crazy stuff, because all of those things are sort of the same idea of generalizing things, but can be used in like different contexts for really large amounts of flexibility in design. But yeah, I think that's basically it. All right, so something I forgot was that you can actually make value types nullable. I kind of alluded to that in the beginning, or alluded to that there's exceptions up here under normal circumstances that value types cannot be null, at least structs cannot be null, which just means value types cannot be null, because that's basically nullability and reference versus value types. It's more or less the same thing. If something's a value type, it can't be null. If something's a reference type, it is nullable. But there's a way to actually turn any value type into something that's nullable. So say int a, and it's not just make an array of 1, because I guess that would technically work now that I think about it. But there's a stupider way. A equals 1, but then you can also do int a b equals 1. You can add a question mark, and that makes it nullable. So what this means is now if I try to do a equals b, that did not do what I typed. No, I don't. Stop. A equals b. No. There you go. It'll get mad at you. And that's because, I mean, a nullable int and a non-nullable int are not the same type. They are different. Because it's nullable, right? But what you can do is if you do, it's like that'll give you an error. But you can still convert them back, right? It's not like always going to be nullable. If you want to make, int, well, you have to do null check. So if heck, why is it doing this so much? It's like overly autocorrecting. I don't know why. If, why, what the heck? Is there a class called if? Oh, I think it's making one. If, oh wait, oh that's why, because I'm not in a function. Ah, okay. Private void. There you go. So I guess let me re-show that then. So now I'm actually in a function a equals b. It'll still get mad at it. Because nullable, right? But what you can do is you have to do it like this. So you have to do if b does not equal null, it should take that, or there's a way to make it take it. Or no. Yeah, you have to cast it. That's what you do. So a equals b. There you go. You can cast it back. So that's how you have to do it. You technically don't need to do the null check. Like you can just do it like this. But you probably should do the null check and figure out what to do if it's null. I don't actually know what happens if it is null, if it errors or what it does. It probably might just give you like a 0 or something. But yeah, you can null check it. And the same idea goes for literally any value type, including structs. So if I do my sample struct from earlier, I can do sample struct s equal, just do new. You know, and I can do the same thing where I can do let's do ns. Let's just do ns. There we go. And now it's nullable. And what this means is that the struct itself is nullable. So like I can now, like if I try to do if s equals null, it gets mad. If I do if and s equals null, it's like, oh, that makes sense. So yeah, you can make any value type nullable by just adding a question mark to the end. There's not an equivalent for reference types, I don't believe, but yeah, so you can make them nullable if you need to. It can be helpful for certain situations. It's a very situational thing to do, but it can come in handy. Just thought I would mention that. And one final thing that I also forgot to mention is just the concept of putting classes inside of classes and structs inside of structs. You can basically do that infinitely. I'll show you. I'm trying to remember my code is here. It is. So let's say you have a class, right? I did it here, but I didn't really go into it. So you have public demo. So what you can do, right, inside of this class, you can do, you know, public class, thinking level 1 public, and you can just keep doing this. I don't think there's technically a limit. You can do this indefinitely. So you can put classes and classes and classes and classes. That's totally a fine thing to do. It's just kind of, probably shouldn't. Like if I were to try to access, you know, the level 5 class here, I'd have to do like public it'd be level 1, because I have access to that here, level 1 dot level 2 dot level 3 dot level 4 dot level 5. It thinks it's more, it's not. Right. You know what I mean? So you can put classes and classes. Right, and the way you access it's kind of similar to a variable, or when you have a bunch of stuff and stuff. It's just you put a dot between them, and that'll go down the hierarchy. So this is level 1 dot level 2 dot level 3 dot level 4 level 5. You can do the same thing in structs. I've never actually tried it, but I'm like 99% sure you can do public. Let's do this. I think it's gonna get mad at me because it needs to. Yeah, you can't use the same name. Demo 2. You can do the same thing. You can also, you notice we have the same things here, right? So we have level 1 here, we have level 1 here. And the reason that is because if I were to try to access them, you know, outside in like another class, I'd have to start with like inception demo 2 dot level 1 versus inception demo dot level 1 would be different. But yeah, I think you can do the same thing with, if I make all these structs, it should also still, in theory, work. Let's see. So yeah, you can put classes and classes. This is can be helpful. In the same way, you can put classes and classes, and it's fine. You also have the same sort of like access modifiers you normally have, so just make this less annoying. So what this means is I can do, you know, I can do public class, and then whatever, and I can do private. I can also do protected. You can do all the same ones. Protected class. Maybe I should go over how protected works a little bit. Private I'm gonna do another thing on that actually. Class. And then if I were to make like another, thing down here of like public class test just to show this off. I always do that. I always do this. Like it's a function. Private func. Private. Oh, gotta do private void. There we go. And then what I can do in here, it's bothering me. I can do a inception demo d, and then if I do d dot, I can do, or wait, no, inception demo, sorry, dot. You can see I can make a public class, but I can't make a private class because, it doesn't have access. It doesn't know about it outside that class. So what this means is if I want to have a class that does like a bunch of other stuff inside of it, where I need to use other classes inside that class, which does come up from time to time, or I don't want to have them external, but I just want to have some internal private class that does something, for whatever reason, I can do that. I can make it private and I'll just do stuff inside there and it won't be accessible outside of that class. Same as anything else. You can also do protected, probably. I actually have never tested this. Let me see what happens if I try that. Let's just do a new one. Protected being the modifier for inheritance, where like it is private out, like basically protected as a modifier is like so protected. Basically, it functions like private normally, but if that class inherits from this class, it works like it can access it. So it's a thing. Protected class. So if I come into here and I now inherit from inception demo, you'll see I'm able to do, I should in theory be able to do dot protected. Yep, yeah, I get access to it. But if I remove that inheritance, I should lose access to it. Yep. So yeah, it works like that too. So yeah, you can use you can put classes inside classes, and you can access them with their scope modifiers, and you can use stuff with that. Same applies to structs. Both those work the same in terms of scope access modifiers. Better just mention that because I think I forgot to go over that.